the controller in this instance is that division bar. So you're going to go after this is log base b of the numerator subtract log base b of the denominator. That's what I think. So it's going to be numerator subtract denominator. Numerator is x cubed y and z squared. Now what? What comes next?
Make that a product.
This is a product, and a product turns into an addition. So log base b of x cubed plus log base b of y minus log base b of z squared. Now I could bring the 2 down if I wanted to. I usually kind of leave that to the last. Now I've got exponents hanging, right? So all the exponents need to come down. This guy has an exponent of 1, so all the exponents need to come down in front. So this becomes log base b, 3 log base b of x plus log base b of y minus 2 log base b of z. Now, like I said, you do enough of those, you'll go from here back to the original problem in your head. And vice versa, because you know how the thing's going to come out. Now, this guy's an ugly sucker. Well, why? Because this becomes x squared y cubed w over z to the 4th to the 1/4 power.
1/3.
Oops, 1/3, thank you. Could use some white tape wherever it is. I know it's not packed, so. It's in my cart, which is far worse at this point. So the first step is to get rid of the exponent, so I'm going to bring the 1/3 down in front. Now, this is where you have to be super careful, because this 1/3 is going to multiply this whole thing, whatever happens to it, and it's going to expand out. Because the first thing that's going to happen is a division turns into a subtraction of the numerator I know that looks like a minus sign. It's a times. That's a times. So then that stinking product turns into an addition. And there are 3 of them. So there's going to be 3 additions. So it's going to be log base 2 of x squared plus log base 2 of y cubed plus log base 2 of w minus log base 2 log of z to the 4th. Now what has to happen? Move the exponents down. This becomes 2 log base 2 of x plus 3 log base 2 of y plus log base 2 of w minus 4 log base 2 of z. I have to cram it in there so I can get it in.
And just leave it.
And I just leave it. And if you think about it, bring the 2's up, then multiply, bring the 3 up. Multiply x, multiply y, multiply w, etc. So you should be able to go from here back to the original. And you can multiply the 1/3 through too. That gives you an alternative form of the, if you wanted to. If I were in calculus, I'd probably have to do that. Now, if it's apart, you can bring it back together. Step one always, by the way, is to bring up the exponents. Because the properties of logs, the sum property and the division one has coefficients of 1. So this becomes log base 3 of x to the 4th minus log base 3 of x plus 3 to the 1/2. Now what happens? A subtraction turns into a division. Log base 3 of, the numerator is x to the 4th because it's plus. The denominator is x plus 3 to the 1/2. And you can leave it as 1/2 or write it how? Square root. Which is what your book will probably do. That's to give you practice on radicals. Either way. Now with this guy, I look at it and say there's no coefficients, so there's no powers, so it's straight subtraction. So what's the answer?
Division.
It's a division. So log base 2 of 3x plus 7 over x. Now if you want or not, you can put parentheses or brackets around that. Sometimes it's easier to do that, especially when we get into equation solving. Now we can bring the exponents up first. Log base 7 of x to the 1/3 plus log base 7 of y. And then a product turns into, a sum turns into a product. Log base 7 of x to the 1/3 times y. And then you could write x to the 1/3 if you wanted to as who?
Radical.
Radical, which one? Which one? Cube root. Either way. Like I said, I'm kind of a quit while you're ahead person.